What's up, guys? How are we doing? Welcome back. So today we're going to be doing 10.5 experimental probability. So up until this point, we've been analyzing data. We've been looking at graphs and charts and determining some interpretations from those and everything else. Today, we're going to deal with probability. So talking about like odds of something happening or not happening and all these sorts of things. So let's get started. So first, let's talk about some vocab again here. So an experiment in general is an activity involving chance. So when you think of that, it just means that if we're doing an experiment, there's at least more than one outcome possible. It wouldn't be much of an experiment if there was only one possible option. Trial, it says each repetition or observation of an experiment. So every time you attempt something, and it could produce a different outcome, that's a trial. And what's an outcome? Great question. It's each possible result of a trial. So like a common one is on a number cube. So if I throw a number cube and I get a 4, that's one outcome, but it's not all the outcomes. The sample space, for example, on a number cube, which we're going to talk about here, number 1, would be that I can roll a 1, I can roll a 2, I can roll a 3, 4, 5, or a 6. There's no such thing as rolling a 7. There's no such thing as rolling a 3.5. Those are my only outcomes, all 6. So on these, we're going to talk about what the sample space and probability of are on these things. So rolling a number cube, the sample space, again, like I said, it is a 1, 2, 3, 4, 5, or a 6. Those are all my possibilities. For spinning the spinner, in this case, you're either going to land on A, B, C, or D. Mr. What if you land exactly on the line? Well, then I guess in that case, we could technically say there's a line, but it's always going to be on one side or the other. Or if anything, you just have to redraw. It'd be like flipping a coin and saying it landed on its side. It's not very likely, so it's not something we account for typically. All right. Probability, the measure of how likely an event is to occur. So when you see what's the probability that, during winter season, what's the probability you have school tomorrow? Well, it's the likelihood over total possibilities. Or if we're talking about, something sports related, I always go back to basketball. If he shoots his free throw, what's the probability that he makes this free throw? Well, if he's an 80% shooter, 80% chance, and so forth. What's the probability that this team beats this team? Well, depends on the record and all these other things. So let's do this for just simple examples. So on these, we're going to write either impossible, unlikely, as likely as not, likely, or certain to describe each event. So selecting a green marble from a bag of white marbles. Well, if there's only white marbles in the bag, how likely is it that you're going to select a green marble? Impossible. Choosing a vowel. Oops. Choosing a vowel from the letters A, M, O, F, P, and I. There's an I there. Don't forget about that one. Okay, a vowel. Well, let's look at our vowels. A, O, I are our vowels. And what are our consonants? M, F, P. So if I were to just randomly select a letter, the probability of choosing a vowel is just as likely as choosing a consonant because there's 3 vowels and there's 3 consonants. So it's as likely, as likely as not. That's how they're phrasing that. It's just as likely to draw a pick a vowel as it is to not pick a vowel. In other words, pick a consonant. Correctly guessing a number from 1 to 3 with 2 tries. Correctly guessing a number from 1 to 3 with 2 tries. Took me a second to understand what it was actually asking there. So they're saying between 1 and 3, correctly guessing a number with 2 tries. Well, let's see here. You can guess 1, you can guess 2, you can guess 3. If you get 2 tries, it's going to be at least likely that you pick. You have a 66% chance that you pick the correct number. All right, let's look at some other ones here. Experiment consists of randomly choosing a colored card from a box. Use the results in the table to find the experimental probability of each event. Okay, probability of choosing a yellow card. All right, so if there's 12, well, let's see how many total there are, because remember, probability is successful outcomes over total possible outcomes. That's what probability is. So let's look at the total here. When I add all these up, 13 plus 12 is 25, plus 7 plus 8 is 40. Yeah. And then it says choosing a yellow card. So that choosing a yellow card would be a successful attempt over total possible is 40. So this would be 12 over 40, which we always reduce in math. So 12 divided by 40 is going to be 0.3 or 3/10, because I can divide top and bottom both by 4, right? So it's going to be 3/10. Oops. Okay, choosing an orange card. All right. An orange is 8 out of 40. I can divide top and bottom both by actually 8. So I get 1 over 5. So 1/5 chance, or 20%. Not choosing a white card. Now, this is where it gets a little trickier. What's it mean to not choose a white card? So is choosing a white card not choosing a white card? No. Is choosing an orange card not choosing a white card? Yes. What about choosing a yellow card? What about choosing a red card? So all of those together would be not choosing a white card. So how many of those options are there? So 7 plus 12, 19 plus 8. Oops. 7 plus 12, 19 plus 8. 27. Okay, so there's 27 possibilities there out of the 40. So it's (27 of 40). And I don't know, can I reduce that? No. So it's just 27 out of 40, which would be roughly, what is that as a decimal? 67.5% chance. Okay. And then it says not choosing a red card. So that would be 12, 8, and 13. So 12 and 8 is 20, plus 13 is 33. So it'd be 33 out of 40. And then that doesn't reduce either. So that's my probability of choosing or not choosing a red card. Pretty likely, because there's only 7 red cards, so everything else is not choosing one. All right. Cook inspects 20 hamburgers and finds 3 of them are missing a pickle. What is the experimental probability that a hamburger will be missing a pickle? Well, if 3 of them are missing out of the 20, it would be 3 of 20. It says the restaurant makes 300 hamburgers. Predict the number of hamburgers that are likely to be missing a pickle. So if out of every 20 hamburgers, 3 of them are missing a pickle. We can do this a couple different ways. I can think of this as 3 over 20 equals X out of 300. And I can think of it as a proportion. This is no pickle out of total. This is no pickle out of total. So I can think of it as a proportion. I can cross multiply here. So I get 300 times 3, which is 900 equals 20x. Divide both sides by 20. And I'm going to get 45. So if we inspected 300 hamburgers, we could expect that 45 of them don't have a pickle. We could also think, 3 out of 20. So 3 out of 20 is 15%. Yeah. So I just need to find what's 15% of 300. So if I took 300 times 0.15, I again would get 45. Either way, you can set it up as an proportion or think of it as a percentage. Either way, you're going to get the same thing. An inspector checks 150 children with bike helmets and found that 21 children are not wearing them properly. Not good. So what is the experimental probability that a child will not be wearing a bike helmet properly? Again, 21 out of the total 150. The inspector checks 500 more children with bike helmets. Predict the number of those children that will not be wearing their bike helmet properly. Again, I can think of this as, I can think of this as a proportion where I make it improper helmet over total inspections, which again is 21 over 150 equals, and it's asking how many will not be wearing a bike helmet properly. So that's X over 500. Again, improper helmet over total. And I can cross multiply. I get 150X equals 21 times 500, which is 10,500. X is being multiplied by 150, so I divide by 150. And so I get X is 70. Or I can go 21 out of 150 is 0.14. You just plug that into your calculator and you'll get that that's 0.14 as written as a decimal. So if I take 500 times 0.14, guess what I get? 70. Again, either way, if you want to think of it as a proportion or you want to think of it as a percentage like this, either way, you're going to still get the same answer. So whatever makes most sense for you guys, I just wanted to give you both options. And that concludes 10.5. Let me know if you guys have any questions at all. Thanks for tuning in.